So the first, this is questions 4 and I believe question 5. Yeah, question 4 and 5. Question 4 clearly would not be on this year's exam. I'm going to still kind of get into it and you can skip ahead if you're not interested. Um, so it's a phenol is a weak acid. It gives you the equation. Again, coefficients are 1, gives you the Ka value here, which is a very small number. So you can assume that you're going to use this equation up top here. And that on the top of the question, you have this is x and this is x. And so you have x squared over concentration is equal to the Ka value. Solve for x, and if you take the negative log of that, that will give you the pH. It then asks you for a certain reaction value, C6H5OH should proceed at a significant rate. The phenol must be primarily deprotonated in order to ensure this blah, 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 blah. So they basically want it to be past the halfway point. So they want more than half of this to have turned into this. And so they're asking what pH, must be, the reaction must be conducted in a buffered solution. On a scale below, circle each pH for which 50% of the molecules are in deprotonated form. The way to do this is to remember that the halfway point, if you take the negative log of this value, that will give you the pH of the halfway point. Because remember, the pKa, okay, is going to be equal to the pH at the halfway point. So you can figure out what that is, and anything above that pH will be the point at which more than half of the weak acid is turned into its conjugate base. It's going to be somewhere above, somewhere up here, obviously in this region, okay, based upon the fact that this is 10 to the minus 10, you're negative logging that. That won't be on this year, so I kept that to 1 minute and 47 seconds. Let's go on to the next one, which will be fair game on this exam. Okay, I look at this right off the bat, and I'm seeing kinetics. All right, and I'm looking, they basically graph the concentration versus time. You can see as time passes, the concentration decreases, and that means the rate is slowing down because the slope is changing. This one gives you the change in concentration over time. This shows you what the initial concentration is right there. Okay, one thing that I see right off the bat, I see the 1 over the concentration graph is giving me a nice straight line, whereas the natural log is not straight. I don't want to give you the answer, but you should remember, this tells you the order of the reaction. Essentially, since this is such a simplistic reaction, okay, you basically have the following things. You have the rate is basically equal to K times the concentration to the 0th power or to the 1st power or to the 2nd power. Once you have that and realize it's one of those three, then you're kind of done, right? So I'm going to go to the questions now. So it says in trial 1, calculate the initial pressure. Well, that's nice. It tells you the initial concentration right there. So originally it's 0.020 molar. That's the original concentration. Remember, that's moles, okay, per liter. So you have the number of moles and the volume, and they're asking you for a pressure, and they're giving you a temperature of 625 K, and it's a gas, okay. I can't get right. I mean, those are things that you're supposed to see. And if you're not seeing them, then that's what's problematic, right? As soon as you're thinking gases, you're thinking Pivner equilibrium. Okay, if they're giving you a temperature and they give you a concentration, they're giving you T, N, and V, and it tells you what equation to use. The second thing, B, says use the data plot in the graph to determine the order. Well, that's what we said, right? So is this 0th order, 1st order, or 2nd order? So remember, if this was straight 0, 1, or 2, that tells you what's what. Now, the next thing you can do is once you determine the order, and it doesn't even ask you to justify it, honestly, which is strange to me, but I probably would have written like one short sentence anyway, just to cover myself if it was a real AP exam. And that says the initial rate of disappearance, so they're giving you the change in, they're giving you the initial rate of disappearance, okay? Calculate the rate constant K for this reaction. You've got choices of how to do this. Quite honestly, if I was doing this, now you can go to the reference table and you can use, once you know the order of the reaction, you can plug in values and determine the value of K. So you can use the integrated rate law if you wanted, which is the one that's in the reference tables. You could use that, okay? Use the initial concentration and the concentration at time T and plug it into the right thing. Now, if you did the first part B incorrectly, but you did the second part correctly, so if you say, let's say if you think it's 2nd order and you use a 2nd order equation and you're wrong, you still get the 2nd point. If you thought it was 1st order and you use the 1st order equation properly and you do that, use the equation properly, you still get the 2nd part right. So if you get B wrong, it doesn't follow through, okay? For me, I think the fact that they're giving you the fact that they're giving you an initial rate, and you can use K equals rate. Uh, rate equals K times some concentration to some value X. If you already determine what X is, um, you know, figuring out K should be really easy. Your choice. All right. And you have an initial concentration too, don't you? So your choice. I think it's an easy question, quite honestly.